Hello students. Today we'll see another data structure called queue uh, that is also similar to the stack, that is also restrictive data structures, but it has different characteristics. So we'll see that how we can build queue and what is the applications of queue and how we can use a queue and how we can implement a queue. We'll see some examples, we'll see some applications of queue. So so if we start with the real life examples, what does it mean queue? So you can see in the slide that there are several people are standing in the queue. That is our real life example. Now, what is the characteristics of this queue? So for example, if you new person is want to join into the queue, then probably you know he will join at the end of the queue. So this person is the last person of the queue. Now if anybody come into the queue, he will join after this person. And if somebody will be accessed or somebody will be removed from the queue, probably the first person will be served first, and probably the first person will be removed from the queue first. So this is the queue characteristics. Whatever you are inserting or whatever you are adding into the queue, that should be added at the back of the queue, and whatever you want to delete or whatever you want to remove or whatever you want to serve from the queue, probably the first person or first element of the queue will be treated first. So this person, you know, came first, came before from before all these persons. So he he joined into the queue before all these person, and he will be served before all these person. That means the first in first in first out. So that's why queue is called FIFO. As we have seen that the stack is LIFO because last in first out. The element that is added into the stack last, and that will be treated first before all other element. That was the characteristics of the stack that we have seen in our previous class. Now we are saying that queue is a FIFO, that means fast in fast out. The element that will be added first into the queue, that should be treated first before all the element. That's why it's called FIFO. If we go back to the previous slide, so this person was the first object or first element before all those elements. That's why he will be served or he will be accessed before all these all these persons. That's why the queue called FIFO, or a queue has the characteristics of FIFO. So the first element inserted in a queue will be processed or removed first. Queue is also a restricted data structures like what we have seen and stack, because you cannot insert anything into the queue anywhere into the queue. You cannot remove any element from the queue. They have some characteristics, they have some rules. So you have to remove the first element, then you have to add something at the back of the queue. This is the rules and regulations to maintain queue. So similarly, the stack, you can implement queue using array list that we have seen for the stack also, and you can implement queue using a linked list like in stack or like in stack. So we'll see those implementations. So we will go to the terminals. So now come to the point that what is the applications of queue? Our computer use queue applications. So for example, our operating systems. So our operating system serves several jobs. Say for example, if you consider say simple printer, so you say for example, so you have a lot of colleagues in an office. Now you you request a from your computer to print something. Your colleague also request a printing command, request a print command to the printer. So if you come before your, if your request come before your colleague request into the in the printer, then your job will be served fast before your colleague request. So our printer basically maintain queue all the task. So the task which was requested first, that would be, served before, all other, all other tasks. So there should be a queue in our, you know in our printers. They maintain some job task queue. So that job task queue keep all the tasks those are requested by different persons. So the requested that is received first, that would be performed first. So we can see that our printer basically maintains some queue applications. Similarly, our operating system to, you know keep track, waiting for resource on end to, and ensure that the tasks are carried out in the order that they were generated. So we requested several, job to our operating systems. So we probably we open a file, then we probably do some operations, other operations, writing email, sending email. There are several job that we request to our operating system to do those things. So our operating system maintains some queue, and those queue keep all the jobs that those are requested by us, and they maintain that queue and they perform one by one using the queue concept to do those operations. So these are the applications in our computers or in our programs or in our, you know automatic, some computer system. So we have seen several methods in stack. So similarly, the queue also has several methods in the queue. So there are some basic operations. So whether you are using built-in queue class that is provided by Java library, or you are using your implementing your own code to create a queue, you write your own code. Whatever you are doing, you probably have some basic methods to implement a queue that we have seen in stack also. So what are those methods? For example, the first method calls offer. So offer method basically insert an item at the rear of the queue. We know that whatever you insert, that should be added at back of the queue, and return true if it's successful. So offer method takes some item that is the E type, that's basically based on your data that you are keeping in the queue. So that offer method inserts something at the back of the queue, and it returns true if it is successful. So if return false if item could not be inserted. So if it is not successful, then it return false. That's why you can see that offer method returns boolean. If it returns true, that means you are succeed to insert something at back of the queue. And if it returns false, that you couldn't insert that element, that item at back of the queue. So this is the offer method, this simple inserting method to the queue, into the queue. So what is remove method? That makes sense. You remove element from the queue. So you can remove from anywhere from the queue. You have some rules. Queue has some rules that you have to remove something from front of the queue. So remove the entry at the front of the queue and return if its queue is not empty. If the queue is empty, then throw in exceptions. So that makes sense that if you want to remove something, that you must have some element into the queue. If there is no element into the queue, then you cannot remove anything. So if queue is empty, then it it returns some exceptions. It throws some exceptions. So this exceptions type is no such element exception. That means there is no element uh, uh, in the queue. If queue is not empty, then probably you will remove the front element of the queue, and it returns that removed element. So you can see that remove method returns E type. So E type basically based on the data that you are keeping in the queue. So remove method, simple things that you are removing the front element from the queue. If queue is not empty, if queue is empty, then it throws some exceptions. Then you go to the pull method. Pull method remove the entry at the front of the queue and return it. Returns the null if the queue is empty. So this is quite similar to the remove method. The difference is that if the queue is empty, then it throw exceptions. The remove method throw exceptions, but pull method, if queue is empty, then it returns null. It returns null. So these are differences. The remove method throw exceptions if queue is empty, and pull method returns null if queue is empty. Otherwise, both are the similar. Both are returns e-type data, or e-type data uh, that is basically front element. That is a front element of the queue. Now peek method returns the entry at the front of the queue without removing it. Return now if queue is empty. So these two methods basically remove the element from the queue, and peek method, it doesn't remove anything, but it returns the front element of the queue. So we have seen that peek method in the stack also, that in that case the peek method basically return the top element of the stack, and now we are seeing that peek method in the queue also. But in the peek method in the queue, that basically return the front element of the queue without removing it. It doesn't remove it, it just return the front element of the queue. And finally, the element method return the entry at the front of the queue without removing it. If the queue is empty, then throw in no such element exceptions. So this is quite similar to the peek method. The difference is that the peek method return nulls if queue is empty. However, element method returns to throw some exceptions if queue is empty. So these are the basic methods that we need to implement if we want to implement a queue. So you have to know that this method in order to handle queue. Let's see some examples. So this one was an example. For example, this is your queue. So if this is your queue, this queue name is names. So if this is your queue, the Jonathan is a front element of the queue, and Rich is the uh, back element, last element of the queue. So Jonathan came joined to the queue before all these persons. So now if you implement, if you call isEmpty method, so names.isEmpty, so names.isEmpty basically check whether your queue is empty or not. So think queue is not empty, thus it should return false. Then the second method, so we call the names.pick. So names.pick method basically return the front element of the queue. So we can see that if you go to the pick method, so return the entry at the front queue without removing it, and returns now if the queue is empty. Since queue is not empty, so it returns Jonathan. So it returns Jonathan. So this is the first element. So it will be assigned to the first variables, that is the string type. Now go to the third method. So names.remove. So names.remove basically remove the first element of the queue. So if you go to the remove method, so remove method delete from the queue, that is a front element of the queue, and if queue is empty, then it throw a exception. Since this queue is not empty, so it will not it will not throw any exceptions. It will remove the first element of the queue. So after you know removing the first element, the queue became this type. Queue become like this. So Jonathan, there is no Jonathan because we already removed you by calling names.remove method. Now the last method, so we call offer, names.offer. Offer method basically insert something at back of the queue. So the Phillips, so you can see that Phillips is the string that you want to insert into the queue, and we know that what is the back element is the reach. So if you want to insert something, you have to insert after reach. So you can see that our new queue after inserting something, so dusting will be the front element, and the fill will be the last element that just added now. So it added after each, that's why it's added after that. So you can find the difference between stack and queue. So in stack we have seen that whatever you insert, you have to insert at top of the stack. Whatever you delete, you have to delete from top of the stack. However, in the queue, whatever you insert, you have to insert at back of the queue, and whatever you delete from front of the queue. So this one is an example of queue. Now let's go to the terminals, and on the terminals we see that how we can create queue in the programs. So let's create a interface. So we create an interface. That interface, we know that interface basically keeps all the method prototype. We don't implement those method in the interface. So let's create an interface called qint, and that basically take e tag that based on your data that you are keeping in your queue. So we first create a offer. We have four different methods in the interface. The first method is offer method, second method is pick method, third method is poll method, and fourth method is empty method. So offer method insert an item at the rear of the queue, and it takes some object that should be inserted, and it returns true if it is successful, otherwise it return false if it is not successful. So this is the offer method definition. So we see that boolean offer and e objects. Then we have a pick method. Pick method basically return the front element of the queue, and poll method remove the front element of the queue, and is empty method that returns to if queue is empty, otherwise it returns false. So we can find out whether queue is empty or not by checking by using the is empty method. Now let's go to we can use this interface, uh, and we can use this interface in our class, which class is used for creating an queue. So let's try with the queue, this one first. So you can see that we have a class, and we call this class the list queue. So we told that you can implement the queue using array list as well as linked list. So this class basically creating a queue using array list. So our class name is list queue, and it takes any e tag data, or it can be anything, integers, float, or anything. So then implements qint. This is our interface that we have built. This one we have just developed qint, and we are using this qint, and we implement all the method that we define in the interface. We will implement those method in this class. So at first we create a list, then the data, the list name is data. Then we have some constructor. In the constructor, the data is allocated by array list class. So it is the object of the array list class. So this queue will be based on array list. Now we implement our all the method. So the first one is offer method, the second one is element method, third one is remove method, and final one is empty method. So you can see that the offer method takes an object, then use the add method. That add method comes through the array list class, array list object. So we can easily add those method and add the object uh, you know at the back of the queue. So whatever you are adding into the queue using add method that will add the element at the back of the queue. So it returns true if if it's succeed, otherwise it returns false. So now element method. So element method basically return the first element, front element of the queue. So how do you find a front element of the queue? So before that you have to check that whether your uh, queue is empty or not. If queue is empty, then it will return, it will throw some exceptions. If queue is not empty, then you can easily find, you can easily use the get method and using the zero index. So zero is the index that contains the front element of the queue. So since it's an array list, so you have some index, it started with the zero, and zero should contain the first element or front element of the queue. So you can easily use the get method to return the front element of the queue. So this is simple how you can create a implement element method. Now let's go to the remove method. Remove method, what it does, it remove the front element of the queue. So before deleting something, we need to check that whether the queue is empty or not. If queue is empty, then it throws some exceptions, that no such element exception. If queue is not empty, then it removes the index, remove the data at zero index. So we call remove method, that remove method coming through the array list class object, and here we use get method that also coming you through the array list objects. So we easily call the remove method that will remove the data at zero index. So how we can easily implement the remove method of our queue. So you can see that all the methods are very simple. So you just use the built-in add method, remove method, and get method to implement element remove of our method. So if you go to the isEmpty method, the last one, the isEmpty method basically check whether your uh, queue is empty or not. So you just use your built-in isEmpty method that coming through the array list object, whether the list is empty or not. If the list is empty, then you can easily tell that okay, this queue is empty, or queue is not empty. So these are the programs that how you can implement a queue using array list. Now you should try, create some queue using array list, and we'll see that how we can create a queue using a linked list. So we have seen interface, how to create interface. We have seen how to create queue using the, uh, you know, uh, array list. Now we can see uh, how we can create a queue using linked list. So here you can see that we know that in order to maintain or build some linked list, we need to create, we have to have some node class. So this total class, the main class name is linked queue, that takes e type and it implements queue int. Similar to the previous examples, it implement all the method that we define, in the queue interface. So it implements queue interface. Now this is the inner class, node class, that we must need in order to create some linked list. In the node class, you have seen that there are two members. The first member is data, and second member is next data reference. So what is the, it contains the address of the next node. Then it has two constructor. The first constructor take one data, and it create a node using the data, but the next field will be null because we don't have any idea what is the next node. Then it has another constructor that takes data and the node reference. So using the data and the node reference, you can create a node. So data item will be inserted the data member, and node reference will be inserted to the next field. So these are the information. So in this constructor, we know that what is our next node, but in this constructor we don't have idea what is the next node. Since in the queue we have to maintain uh, front and back, that's why we are maintaining in our linked list head and tail. So front will be used for inserting something, sorry, deleting something, and tail will be used for inserting something into the queue. That's why we are maintaining head and tail. Head is a front and tail is a back of the queue. So then we can use those two variables to maintain our back and front. So let's implement all the all the method that we define in the queue interface. So the first method is offer method. So offer method to insert something into the queue. So we check that if head is null, that means there is no any element in the queue. Then we just create a head, and we just create that node object, and we pass this our newly inserted object that will be the data of our new node, and that will be treated as a head, or that will be treated as a front. And what is the tail? Tail would be the same thing, because we have only one element at the beginning when we insert only one element to the queue. So we'll have the we'll have the same element for head and tail. However, when you insert another element, then you will have the different tail, or you will have the different back. So if head is not null, that means we already have some element in the queue. Then you add tail dot next. You will create a new node, and that new node will be assigned to the tail dot next. That means tail is your last element, and you are inserting new element after tail. So your tail dot next will be your new element. That means you are inserting something after the tail, and then you will have new tail. Okay, you have new tail will be assigned by tail dot next. Obviously, when you insert something at the back of the uh, queue, so your last element will be the new element. So the before inserting this element, your tail was one element, and after inserting new element, your tail will be the new element. So this one is the offer method. What about the remove method? Remove method is if is we before trying to remove something, we check that whether is empty or not. If it is not empty, if it is empty, then it throws some exceptions. If it is not empty, then head.data. Head.data is our front element of the queue, so that will be assigned to the results. Then our head will be changed to the next element. Okay, so it's kind of a deleting head from the linked list. So it's kind of a deleting head from the linked list. So here in the queue we are deleting from the queue. So head will be your head will be changed to the changed to the next element. That your current head will be replaced by the second element, your second element of the queue, because front element will be deleted. So this is the how you can remove. Now element that basically return the front element of the queue. So before returning something, you will check that whether your queue is empty or not. If it is empty, it will throw some exceptions. If it is not empty, then it returns head.data. So this is the head.data is your front data, front element of the queue. That's why it returns head.data. And finally, you have the isEmpty method. So how you can implement isEmpty method? IsEmpty method check that whether your queue is empty or not. You can check easily. If head is null, then you can say that your queue is empty. If head is not null, then you must have at least one element in the queue, so it's not empty. So you can call this all isEmpty method in all other all other methods. So this is the how you can implement a queue using the linked list. So you have seen that you can implement a queue using array list. You have seen that you can create a queue using a linked list. So these are the way how these are the way how you can implement uh, a queue in your code. But if you want to use built-in queue, you don't need to implement offer, remove, element, or isEmpty method. These are already implemented in Java library. You just create an object of the queue class, and you can access their method. These method already already been developed or implemented, so you don't need to write a code those things. So but in order to make clear that how those methods are working, that's why it's a good idea that you should try implementing queue in your code. Then you will have the better idea how to deal with queue and how they are working. So this is the two important structure we have covered in the last two classes. So the first one was stack, and this one is the queue. We'll see some more data structures in futures, and we'll see some other queue informations, other queue classes in the next slides or in the next class. Okay, thank you very much.